Alright, in this problem, number 5, we have discontinuity again, but in this case we're just using limit notation to describe the discontinuity. If you look at the given statement, it tells you something about our discontinuity. It tells you that you have a graph, the F graph, and as you approach 4 for x on that graph from the left side of 4, your limit or your target value is 8. But that at 4, you really have an undefined position or point on your graph. So I'm going to represent this graphically by locating point 4, 8. Assume this is, and I'll just put a little dot there for a second. Oops, little dot. Alright, I know that as I approach it from the left end, or left side, that's what this superscript is, this negative. Remember, this has meaning. You're approaching 4 on the graph from the left side. So I'm going to say that I'm approaching it. Here's my graph approaching 4, but that when I reach 4, which is at 4, 8, that really it's undefined. So I could have several things going on here. I could have jump discontinuity, I could have a hole where it really doesn't fill in at 4, 8, or I could have infinite discontinuity. Something's going on, but I'm not sure what. Well, because there are 3 possibilities, question A says, assume that the reason it's undefined at 4 is because there's a removable discontinuity when x is 4. So that means that I have a point discontinuity, I have a hole, if you will, and I will represent that by putting an open point at 4, 8. Now, how can you write that so that it expresses to the reader that you do have point discontinuity by using a limit statement? Well, the limit statement here says, as you approach 4 from the right side, remember the superscript plus means from the right side, you have a target value of 8, but it doesn't exist. So that means somehow you're approaching, I'm just going to assume I'm approaching this way. And from the left and right side of x equals 4, I have a hole, but the hole occurs at 4, 8. Now I'd like to make a comment about this notation. Technically, as x approaches 4 from the right side should be under LIM, as that should be under LIM. Sorry for the correction here, and that's what it should look like. So basically this little expression here belongs right under LIM. Alright, now let us assume once again that we have a position at 4, 8 where we have a hole, and as you approach it from the left side, as you're coming in from the left side, you hit this hole at 4, 8. But the other part of your graph, coming from the other side of 4, is not a hole, but it is a jump discontinuity. And I can pick any number I want for y except 8. So I have chosen 6. So let us say that at 4, 6, you have another piece of the graph, let's say this, and that its y value is 6. Now, I've kept this open because it says it's undefined at 4. So it would not be a closed piece, but it would be an open piece in both parts. And I can do that by using the notation limit. Once again, I would like to see limit as x approaches 4 from the right side of my function f is any number I want but 8, and that shows jump discontinuity. Alright, on the same page I have another problem because these are rather short. And this is from Unit 1, where we were revisiting our rational function that you had studied in Algebra 2. And when I teach this, I say rational function means a fraction. And back in arithmetic, you learned it was okay to have 0 in the numerator, but it was a big no-no to have a 0 in the denominator because that makes the fraction undefined. Based on this, when I have a rational function, I'm trying to determine what values of x would make this function discontinuous. And that would be when you have a denominator which has a 0 value. And that would occur when x is 3. I don't care if the numerator has a 0 value. It's okay to have a 0 in the numerator. That will not cause discontinuity. Therefore, I can eliminate two answer choices. C, it doesn't matter if x is negative 4. It doesn't matter if the numerator is 0. And D. And A is wrong because it says the function is just continuous everywhere. Well, no, it's not. And you have to remember, rational functions are discontinuous if you have 0 in the denominator. So that's not right. So by elimination, I could say that this is going to be true, that there will be discontinuity when x is 3 only. And that's me.